Hi, I'm Radian. I welcome you all to Mathscriber. I am in the process of creating a complete theory course of combined mathematics. This is lesson number 4 of Trigonometry tutorial series. In the previous lesson, I discussed about how to find remaining trigonometric values when one trigonometric value is given. In this lesson, I'll be introducing the SI unit of angle measure, radians. In all levels, though you must have done all the calculations of geometry using degrees, when you come to do A-level maths, you must be familiar with the angle measuring system of radians. So here I'll be explaining the basic concept of radians and how to convert radians to degrees and degrees to radians. Before I start, I must say, if you are fond of learning advanced math stuff, please click like and subscribe. And to get to know about A-level classes I conduct, visit mathscriber.com or dial this number. So here we go, let's get started. In A-level combined mathematics, we hardly use degrees. We use radians in almost all the cases we deal with. So what's the basic concept of this radians? Now, if you consider a sector with arc length C and radius R, and if we are measuring this angle by radians, now let's say this is theta radians. We define theta radian by arc length over r. Arc length divide simple r. So this is the basic concept. Now we can derive two formulas with the help of this basic concept. So if you are supposed to find the arc length and the angle given in radians, so you can find the arc length by r theta, and just for your additional information, I must say, if you are supposed to find the area of this sector, we can find it by, I'm mentioning A for the area of this sector, by half r square theta. Remember here theta is measured not by degrees but by radians. So now if you consider a semicircle, a half circle, now you remember, now in O levels you must have learned, if there's a circle and the radius r, the circumference of this circle is 2 pi r. And if you consider a semicircle, and as you know, this is 180 degrees because it's a straight angle. But now let's say we are measuring from radians, so we don't know how much it is, so we mention it theta radian. If it is measured from degrees, we know already this is 180 degrees, but since we are measuring from radians, we don't know how much it is in radians, so we mention it theta. And let's say this is r, and now complete circle circumference is 2 pi r, but this is a semicircle, so half of it, it's pi r. So this arc length will be pi r. And with this definition, theta radian is equal to C over r, we can say this theta is equal to C over r. C is arc length, which is pi r, and radius is simple r. So we get theta equals pi. But we know in degrees this theta should be 180 degrees. So this has to be 180 degrees if it is measured from degrees. So we get this very important relationship, which is radian pi is equal to 180 degrees. So this will be the foundation of converting radians to degrees and degrees to radians. Okay, so with this idea, having this idea inside your mind that pi radian means 180 degrees or 180 degrees means pi radian, you can convert any degree in any angle which was measured by radians to degrees and any angle which was measured by degrees to radians. So I'll be doing few examples. to explain how the radians has to be converted to degrees and degrees to be converted to radians. So let's look few examples. So how to convert a degrees angle to radians and radians angle to degrees. We'll write here degrees to radians, and here I'll be doing how to convert radians to degrees. Now if you remember the basic concept, we learnt 180 degrees means pi radian. That means 1 degree means pi over 180 radian. So moving on to the first example, how we are supposed to convert 60 degrees to radians. Now 1 degree means pi over 180. So to convert 60 degrees to radians, what we do is we multiply 60 degrees by pi over 180, because 1 degree means pi over 180. So 60 degrees, 60 multiply pi over 180. So it will be just up and down when you cancel by 60. So 1, this is 3, so it is pi over 3. Now moving on to the next example, let's say 135 degrees. So 135 degrees, we are multiplying by 1 degree means pi over 180. So we can cancel up and down by 45 degrees. 45 into 3 is 135. So cut by 45, this is up 3 pi, and 4 into 45 is 180 degrees. So cut by 45, down it will be 4. So final answer will be 3 pi over 4. Now moving on to the other side, how to convert radians to degrees. That's more simple compared to this previous conversion method. So as you know, pi radian means 180 degrees. We simply have to substitute 180 degrees when there's pi in any angle measured from radians. Now example 1, now let's say pi over 6 radian. Now you may bother why I didn't write radian here. The reason is, in combined mathematics we are always dealing with radians because that is the SI unit. So we are not so bothered of writing radian. Most of the time we are using without that RAD, but that's okay. If you write write radian, that's really nice, but if you don't write, it doesn't matter much. Okay, now pi over 6 radian, to convert, instead of pi we just write 180 degrees. That's all what you have to do. So 180 divided by 6, so will be 30 degrees. So moving on to the last example, now let's say 3 pi over 2 radian. So instead of pi we are substituting 180 degrees, so it will be 3 multiply 180 degrees divided by 2. 180 divided by 2 is 90, 90 into 3 is 270 degrees. So that's all for these examples. And as I am saying again and again, to master these theories you must do more questions, and I am only doing these questions just to support the theoretical guide, because my basic purpose is to create a complete theory guide of combined mathematics. So that's all for this video. We'll meet with a new topic in the next video. Till then, goodbye.